Hey students, I hope you're doing well. I miss you. I enjoyed watching your videos and explanations for your tests. I know that seems silly, but I got to see some of your personality and I missed that. Today we are going to be continuing looking at 6.4, and so learning targets are going to be still to write exponential functions and to use and identify exponential growth and decay functions and solve real life problems. So yesterday we looked at exponential growth and how to write functions using this formula right here. And today we are going to now instead focus on decay. So let me scroll on our notes here. Exponential decay is when you have a situation where it is decreasing. So I often think of the decay starts with a DEC, so decreases also starts with DEC. So decay and decreasing means the same thing. So we're going to be using almost the exact same formula as yesterday, except for the fact that it is going to be a minus symbol in between the parentheses. So when I'm decreasing, I'm decaying. That part in the parentheses is 1 minus your r, where r is still your decimal. So it's going to be the percent that it's decreasing by, but you got to convert it to a decimal by dividing by 100 still. And if it was growth, which was yesterday's stuff, when I had growth, I'm going to do 1 plus r. So note the difference between those two. Growth, think I'm going higher, so adding. Decay, I'm decreasing, so I'm going to subtract. And the rest of it stays the same. So we're going to look at using an example with that. So we're actually going to skip farther ahead all the way to example 6 or 7? 7, a minute, okay? I wonder what example 6 is. All right, example 7. So with this example right here, we have the value of a car is the value of a car is 21,500, and then it's losing its value. So loses, think decreasing, it's going down in value 12% each year. So what we're going to need to do is first write a function that represents the value of the car after t years, graph it, and then estimate what the value of the car is after 6 years. So the first thing I'm going to do is I'm going to go ahead and write out just our generic equation a moment. So a parentheses 1 minus r to the t. So our starting amount is our a value. So it says that the value of the car is 21,500. So okay, we're starting with 21,500 for our a. So I'm going to start my equation with 21,500 parentheses 1 minus r. R is once again the percent that it's decreasing by because it's minusing. So that percentage is 12% here. But I don't put in minus 12 in my parentheses there. I have to convert that 12 to a decimal. So I'm going to divide it by 100. And that's going to give me 0.12. Another option is for you to go ahead and move your decimal place just 2 places to the left. So it would be 1 minus oops, sorry about that. 0.12 to the t. And then I would go one step further and I'd actually simplify that out, and I would go ahead and do the math in my parentheses, and I would get 1 minus 0.12, and that would give me 0.88 to the t power. All right, so that would be my answer for the first part. We're skipping part B, and we're going to go to C. C says graph the function from part A. So to graph it, the best thing to do is to make a table. And so in this case, our table, it would not make sense to do negative numbers, like -1 would be like 1 year before, but maybe it's a brand new car, and so that doesn't make sense to say, hey, before it's even made, this is what it's worth. So we would start at 0 on our table, so 0 years. And then I know my go-to is like 1, 2, 3, but I want to predict, if I'm looking forward a minute, and I see that I want to predict what's the value going to be after 6 years. So at 6 years, what's the value going to be? So I personally don't want to have to just have 1 and 2 and then have a graph that I'm trying to go way off the graph to estimate where 6 would be on my graph. So another option is to go like 2, 4, 6, 8. A problem with that is, of course, if I'm if I'm actually using 6 in my table, then why am I even using a graph? So I'm going to be a little tricky, and I'm going to go 1, 3, 5, 7. So I'm going to not use the numbers, even though I could have gone 0, 1, or 0, 2, 3, 4, 5, or 0, 2, 4, 6. I'm choosing not to have 6 in my table so that I can actually use my graph to estimate versus actually using the equation to get the value. So how do I get each of these numbers? And the y is I'm going to just take turns plugging this in for t. So I'm just going to take turns plugging this in for t, each of these numbers. So if I plug in 0, I get 21,500. Now I've got to do a little bit of work here. I got that right. So then I'm going to go ahead and plug in 1 into my calculator. And when I do that, I get 18,920. And once again, double check on your calculator that you're able to do these values and get these same numbers here. It's just good practice to make sure you know what you're doing. Some of you are going to have to do the exponent part first, so 0.88 to that power and then times it by the 21,500. Some of you can do it all at once, just depending on your calculator type. So for 3, 14,652. For 5, 11346. And then for 7, I plug that one in and I get 8,000. Oops, I get 8,786.5. So 50 cents. So now I can finally make my graph. So I'm going to go ahead and make this over here. So T is years. So I'm going to have years. I'm going to start at 0. 1, 2, 3, 4, 5, 6, 7. And then I need to go up to 21,500. There's more than one way to scale this one, the value in dollars right here. I'm going to go by 5,000s, I guess. 5,000, 10,000, 15,000, 20,000, 25,000. All right, and then you're just going to go ahead and plot your points a minute. So I'll use a different color for that. So 21,000, so 0, 21,000, I'm going to approximate is right there. 18,900 for 1. And then for 3, 1, 2, 3, 14,000, so just below 15,000 there. For 5, I gotta count them, I didn't label very nicely here. I get 11, oops, went a little bit over there, 11,000. Then for 7, I get a little over 8,000, or closer to 9,000. So it doesn't look perfectly curved. It should look a little bit better. Hopefully yours looks a little bit better than that. But that's kind of the idea. When it's decreasing, it is going to be a graph that always goes down like that, okay? And starts to level off at the bottom, getting closer to the x-axis but never touching it kind of idea. So that's my graph that I have. So now I can use that to estimate what the car value is after 6 years. So here's where 6 years would be, right? So I could go up here and then I can go over and I get approximately a little over 10,000. So I can say, I don't know, approximately 10,000 or maybe 10,200, whatever. You can just approximate that because that's what a graph does. It's not going to give you the exact answer. If I wanted the exact answer, I would have then used my equation. All right, so that would be just the same idea as before, but of course now making sure that we use that minus in our formula when we're decreasing. Let's see if we can quickly go back to another example a minute. I want to go to example 2. All right, so we're going to jump ahead there and we're going to go ahead and look at how do I tell from a table whether something is exponential or not? So exponential growth, decay, or neither. So what I'm going to do is I'm going to look at my x values first. In the first question, I see it's going 0, 1, 2, 3. So I'm going up by the same amount each time. So then I say, okay, what's going on with my y's here? Oops, I need to this. All right, so my y, you can think of it as, am I multiplying by the same number? And what number am I multiplying by? So of course you see it's going down, but I can be multiplying by a number that's not negative, but a decimal to get me a smaller amount. So how do I know what I multiply by? Is actually go to the reverse order and take the more recent one divided by the previous number. So 90 divided by 270, oops, I'm in the wrong spot. 90 divided by 270 gives you 0.3 repeating, so 1/3. So I can try that again with the next set, read these two numbers, so 30 divided by 90, and that also gives me 1/3 or 0.3 repeating, and I can try that for each of them. So each time I am reducing it, I'm dividing by 3, which is the same thing as multiplying by a constant of 1/3. So this is, since it's going down and I'm multiplying by a number of 0.33 repeating, this would be called exponential decay. On this next one here, on B, I go up by 1 each time, right? +1, I'm adding +1 here, +1 here. So then my y's, let's see here, I could not adding, well I could add 5, but then that doesn't hold true for this one. So another way I can get from 5 to 10 is I'm timesing it by 2, right? And then 10 times 2 would also give me 20, so I'm timesing that by 2. Here I'm timesing it by 2. So hey, I'm multiplying it all by a constant or the same number each time. So this would be exponential growth. Basically, if you're multiplying by a number for growth, if you're multiplying by a number greater than 1, it's going to be growth. If you're multiplying by a number that's between 0 and 1, it's going to be decay. And I put that B there for in between that, and this is technically B right here because I remember our generic equation, the B is that growth or decay factor, what is it being multiplied by. And then quickly on example 3, it says determine whether it's exponential growth or decay. That will help me if I look at this information I just kind of went over right here, is right there. Look at that B value. The B once again is from up here. Okay, so that B is going to tell you in an equation whether it is growth or decay. And so if I look at A right now, my B is in my parentheses, it's a 1.07. So hey, that is a value where B is greater than 1, right? So B is greater than 1, so this is going to be a growth. And then you're asked to identify the percent rate of change. So that's kind of going back to, if it was growth, remember that formula that we looked at yesterday where I had y equals a parenthesis 1 plus r to the t. So they're asking you to basically find this r right here and convert it to a percent. So if this is a 1, I had to do 1 plus, in that formula. So I got somehow, when I did 1 plus something, plus r, I got 1.07. So some of you are going to say, hey, I can just solve or do mental math, and you realize that r has to be 0.07. But then as a percentage, that was, because it is a decimal, we learned we divided by 100, but I want to convert it back to a percent. I would times it by 100, and that would give me 7% would be my percent rate of change. So those would be my two answers. And then the last example, you can look at your B value right here. See how that B value is between 0 and 1. So this is going to be a decay problem. And how do I find that R value, that percent rate of change? Remember, when it's decay, that part in the parentheses is 1 minus R. And so if I got 1 minus what gave me 0.98. And so some of you can use algebra, etc. Some of you can just use mental math, and you're going to get 0.02. Right? 1 minus 0.02 gives me 0.98. But I want to convert that to a percent. And so as a decimal, so going backwards, instead of dividing, I'm going to multiply, and that's going to give me 2% for my R value. Okay, so I have decay, and it is going to be R is 2%. So you're going to practice a couple of these problems for your assignment tonight.